Hello and welcome to another episode of Let's Make It. This is episode number 50 and is recorded what's today, the 20th of January already of 2014. And tonight we're going to cover some SD card stuff and some Raspberry Pi stuff. And as almost normal, I have Bob with me tonight. Say hi, Bob.
Good evening.
How are you doing?
I'm doing good. How are you?
I'm doing okay. Did you have a day off today?
No. It was a regular day for me.
Oh, I had the day off, but it doesn't feel like I was off. So it was a day of doing things around here, it seemed like pretty much. So kept myself really busy.
That happens.
That's the way it works, right?
That's right.
Days off aren't days off so much recently. So
when you got a house, yeah, that's right.
Yeah.
Days off or not days off.
That's right. And we're supposed to get a big snowstorm tomorrow too. So
enjoy.
5 to 8 inches of snow, which doesn't sound like a lot to some people, but for us, it's pretty bad typically around here. I want to say again, thank you to everybody who's spreading the word around of the show. The show is like really growing nice and fast and getting lots and lots of emails. And this week has been very interesting with some of the emails that we've been getting going back and forth. Actually, I have a question for you, Bob, and I haven't really responded. We've been going back and forth with somebody about this timer. You know, we did the timer countdown a few months back, and somebody wanted to convert it to milliseconds. And I don't know if the display update can work that fast with the I2C update.
No, it can't. Yeah, there's actually been, I think, 3 different people that have been asking about that. And one of them, they really needed a real-time clock to do what they wanted to do. And one was just interested in, could they do it? And the problem is the display, it's too fast, updating that quickly, it's too fast for your eyes.
Right. Well, it's too fast for your eyes. I think it's too fast for the I2C protocol as well to do once a millisecond. I did a little test, and just looping through the Arduino code was slow enough that you could push data out to the display and get it to work, but it was so fast that you couldn't see anything. Right. This person wanted to time a welding type machine. I guess they're welding something to batteries or something, and they needed exactly like 9.9 seconds, and they wanted to do it down to milliseconds, and they're asking me how to change it. I sent the code to like basically wait for 9.9 seconds, 9,900 milliseconds, and they wanted to take it and put it into the same sketch, and then I need to reply to that. I don't think it's going to work. I mean, the way our time worked before was we waited 1,000 milliseconds to assume for a second, but if you put it down to 1, it would probably do what he's trying to do. I don't think the display would handle it.
Yeah, the display is not going to handle it. And you could, and I've corresponded with him as well. And you can get close to the exact time that he's looking for, but it's still going to be a little off because the Arduino just isn't going to time that perfectly.
Right.
So, but he's looking for a very precise time, and I think the Arduino can come really close. Just not a millisecond close.
Right. Well, I don't think he cares exactly the millisecond as much as it's 9.9 seconds or 9,900 milliseconds. I think a couple milliseconds probably wouldn't matter. So,
no,
I sent him the code to sit in a loop for 9.9 seconds based on milliseconds. So, but I think you want to take it a step farther than that. Also, did you see the email about the guy who's doing the high altitude balloon stuff?
I did see the email. I have not corresponded with him.
I sent back an email to him because I'm very curious about that kind of stuff. So, but he did reply back and explain some of my questions about it, and it sounds very interesting. I'd like to go to a balloon launch sometime and just kind of watch what all goes on with it. He sent me a picture. He sent me a picture from high altitude too that he took.
Oh, okay.
It was really cool.
Well, send me that picture then.
I will. I'll send it to you.
I haven't seen that one yet.
Yeah, I was very excited to get that. He wants to try to do stuff with the Arduino. He's been using something that's kind of like off the shelf, purchased from like a kit place or high altitude kits or something like that. I can't remember what it's called.
Oh, okay.
So specialized parts, but he wants to do some stuff with the Arduino. So it was very interesting. All right, well, let's go ahead and let's see. Oh, we have a couple of people in the chat room. Jim from Canada is on the chat room, and Robbie. I think Robbie may be the first time in the chat room. I think I've seen Robbie. Welcome, Robbie. Okay, so today we're going to talk about writing to an SD card. So real quickly, let's hop over here. I'm going to show you what I have. And I actually have the same stuff from last week. I have the temperature sensor, and I did get it working. I did figure out what the problem was. I don't necessarily know why that was a problem, but it didn't like the pin that I had it in. I had it in pin 4. It only likes to work in pin 2 for some reason. So that could be something hard-coded in the library that I'm not aware of. Haven't had a chance to come back and actually take a look at it. But we're going to use the same shield, so it's exactly the same thing we had last week, because on the Ethernet shield is this SD card right here, and I have an SD card in here. Actually, let me unplug this and take the card out, and I can show you the card. Let me unplug it. Where is it? There it is. And eject this card. It's the tiny little card, but I have a 2 gigabyte SD card that we're going to write to on here, and we're going to write and destroy and all kinds of other things with it tonight. So let me put this back in. And then I have the temperature sensor here. So the first thing we're going to do is we're going to show you how you log data. So let me plug it back in. And then I'm going to hop over to the code. Let me get the data logger up and go over to the code. So here's our code. And going to start at the top. And basically the sketch is an example as to how to log data. And we're going to log the temperature every 60 seconds to this card. And this is something that actually, after I saw how much data this card can hold, so 2 gigabyte you don't think about these days as being very much, but for us writing out temperature, and we're storing the temperature in centigrade, Fahrenheit, and we're also storing the humidity, takes 9 bytes. So if you consider 9 bytes every 60 seconds, it would take 417 years to fill this card up.
I don't think we're going to run out of space.
No, I wasn't thinking 2 was very much in my head when I was thinking about, writing this. So, and I calculated out just out of curiosity how long it would take to fill it up. So at 9 bytes, the card itself is a little less than 2 gigabytes. You see it's right here. What is it? 1.9 billion bytes, not 1.975287808 bytes. Lots and lots of bytes. So, all right, we're going to scroll down here. So, because we are doing the temperature reading, we need to have the wire and the DHT11 like we had last week in the web server. And I want to say I started out trying to make this a web app because I was going to show you how you can read the logs from into a web page that's on an SD card. However, the Uno does not have enough program space to support all these libraries that are needed to do this. I had to get rid of the web server. So I went back to just the straight serial interface. But we include our wire, our DHT11, and then here is sd.h, which is the card library. We define our DHT11 chip right here. And because I originally did this in a web server format, you're going to see I did my timer a little bit different because the web server needs to be maintained even when you're waiting to do the next read. So I just didn't want to put in there wait for 60 seconds because I need to have the web server be able to run itself. So the way I did the timer is a little different. We see that when we get down here. And then you see I come down and I begin the serial port. I set pin mode for 10 to output. And this is important. Pin 10 has to be output for this library to properly work. Even if you're not using pin 10, which is basically for the card select, it has to be set because it has to be able to be controlled by the library even if it's not connected. And we come down here and we check if the card is present. And we're checking pin 4, which is what we're saying is the card. And if it's not there, then we say it failed or it's not present. And if it's there, we say it initialized. So you hope it comes back and says card initialized. And then I define a string because we're going to manipulate some strings down here in a little bit to create the log file. And I just make it equal to blank as it comes into the loop. Then the next log time, here's where the next log time is. Before I had the web server, this line right here was the web server maintenance line. And then after it finished that, it would come down and say, is it time to write another entry? So if the next log time is less than the current time in milliseconds, then we're going to open a data file called datalog.txt, and we're going to write it in write mode, file write mode. And then if all goes well, it's going to come down here, and if data file, we're going to then read the number from the sensor. And if the sensor reads okay, we're going to create this data string. And basically all it is a string of the temperature in centigrade, a comma, the temperature in Fahrenheit, a comma, and the humidity, and a carriage return. And then we're going to write this line to the data file. And just like the serial port, you just do .print or .println if you want a carriage return at the end of it. Now you see I'm adding a carriage return. I'm doing that because I want it to be double spaced in the file. You could just do print if you want to do one line per. And then we come down here and we close the data file, assuming that we had it open. So for in the data file, if condition, we've had it open. So we need to close it even if the temperature doesn't read properly. And then I want to print to the serial port also what we're printing to the file, just we can kind of see it working. And then I'm going to set my next log time equal to the current number of milliseconds plus log delay, which I set to 60,000 at the top. So that's it for the data logger. It's a whole whopping 90 lines long. So I'm going to go ahead. I'm going to upload this. All right, and let's go, and we're going to look at the serial monitor. So there you see it's currently 23 degrees Celsius, 73 degrees Fahrenheit, and 34% humidity in here. And after 60 seconds, it's going to do this again. And I'm going to let it run one more time because I want to put a little bit more data into the log file. There's some things in there from before when I was playing with it, but I want to add at least 2 in from this room because the other room was a little bit cooler where I was working.
And you're just sending this as ASCII text to the file, correct?
Right. So this is basically the same thing as a CSV file. So if you would import this file into Excel or something like that as a CSV, it'd be a column per. But we're also going to show you how you can read the data in the next step. And 60 seconds feels like a lot longer than 50 seconds when you're sitting here waiting for it.
Yeah, sure does.
I kind of probably made it lower. Okay, there it is. So now we have at least 2 entries in our file. Actually, I'm going to let it run while we go through the next one anyways before I upload it. So it'll get some more entries there. So let's go over here and bring up the data reader. So this file, this sketch does exactly the opposite of what the write does. It actually reads it. So if we scroll down through here, you're going to see the only thing I have is an sd.h because I'm not reading any data from any kind of sensor. I'm actually reading the actual file, and the only thing I need is sd.h. So I'm going to set up the serial port. Again, I'm saying pin 10 has to be set to output for this sd.h library to work properly. And then I'm going to start the SD up with pin 4, with the card on pin 4. And if it fails, it's going to print out that's failed or not present. Otherwise, it's going to print out the card initialized. And all we're going to do in this loop is we're going to create a pointer to the file and then it's going to point to the file of datalog.txt. So sd.open opens the file of datalog.txt and then has the file pointer in the variable called data file. And assuming that the pointer exists and it's not false. So if this file doesn't exist, this is going to come back and it's going to be equal to false. So the file is available. We're going to loop through it by doing data file.available. So while we still have data we can read, it's going to be true. And when we're going to write to the serial port, one line at a time. So every time you do a data file.read, it reads in one line of data. And we're going to stay in this loop until we run out of available data. And then we're going to close the data file and we're going to put 2 blank lines. This way we know where it stops. And then if the file doesn't open for some reason, like it's missing, or it's going to say error opening data log. And we're going to wait 30 seconds and we're going to print it out again. So let's go ahead and upload this sketch. And we're going to go to Tools and do the serial monitor. And you're going to see right away that it's going to print out the data. So you saw when I was first playing with things, I have a couple zeros in there, and then I had some zeros right here. And then I finally figured out that I wasn't initializing the DHT11. And we started getting 21 degrees Celsius, 69 degrees Fahrenheit, 35% humidity. And you can see here we are in this room. There's a 75, a 73, 73. So you can see where I changed rooms from my desk to the studio here. It got a little bit warmer in the studio. So we're basically reading that file around in a loop every 30 seconds and printing out this data. So we could keep running that data logger for years and come back and run this and get the data out. Or we could put this same card into a laptop and read the data off the card. because that's the whole idea is you want to be able to exchange cards. You put a blank card in, take the other card out, stick it in your laptop, import the data into Excel or whatever. All right, so the other things we want to do with this card is, let me bring up the card info. So now we want to see what's on the card, or how big is the card. We want some basic details about the card. So this sketch is going to do exactly that. Oops, I'll get back in here. Too many fingers. All right. This sketch, if we scroll down here, basically only has sd.h included, but we have some additional data structures that we need to define. sd.h has these data structures in it: sd to card, sd volume, and sd file. So the sd to card is a data structure that holds card information, and the sd volume holds volume information, and then the sd file holds the file system information. So we're going to come down here, and we're going to, again, start our serial up, do the same thing with pin 10, and start up our card. And when we get down here to loop, what we're going to do is we're going to init the card. So we're not doing the SD like we were up here. We're actually knitting the card. And we're going to say it's SPI half speed. And there's a couple different options in here for speed, but it seems like from what I read, half speed is probably the most stable. And again, we're on pin 4 right here. If everything connects, it's going to say it's connected. And then it's going to come back and it's going to start, when you initialize the card, it pulled back all this information about the card. So we're going to do a little switch statement here. And based on the type of card, we're going to print out to the serial port what type of card it is. So SDHC is a very popular card, but these little cards are SD2s or 1s, I can't remember now. And you'll see that when we go through this and run this. And then we're going to come back and we're going to say, we're going to do the volume. So did we get volume information about this card? So we init it right here, and if it cannot get volume information, it's going to print this error out. But if it does get volume information, we're going to come down here and we're going to print that the volume type is fat, and then we're going to print the volume fat type, which is either 16 or 32 for a 16 or 32-bit fat partition. And then we're going to come down here and do volume size. So the thing about SD cards, and I didn't know this until I was writing this, is every block on an SD card is 512 bytes. That is not the case on hard drives. So it's something that's not the same as a hard drive. But because it's known that it's 512 bytes, it's pretty easy to calculate. So right here we do volume blocks per cluster. And then we do volume size times cluster count. So we know volume size is equal to 512. Then the cluster count is how many total clusters there are. And then we have the 512 bytes per. So volume size ends up being the total number of bytes. So I think I said that right, didn't I? Blocks per cluster is how many blocks are in a cluster. And then there's how many clusters in each. That gives you total number of blocks times 512 is total number of bytes.
That's right.
So right here we do volume size bytes, and we print out the volume size. And then we do kilobytes. We just divide the volume size by 1024. And then to get megabytes, you divide volume size by 1024 again. So we'll get that stuff printed out. And then we actually go out and we open the root file system. And when we perform the ls or list command on the root file system, and we want to print out this information, which basically the name, the date, and the size of the files. Print out 2 blank lines so we know where we stop. And then we're going to wait 30 seconds. So let's go ahead and upload this sketch. And we're going to go to serial monitor. And when it starts running, so there we see card initialized. The card is present. It's card SD2, formatted as a FAT16. Here's the total number of bytes that's available, that's on this card, total number of kilobytes, and total number of megabytes. And this is the structure of the file. So we have 2 files on there right now. We have one called example, and this is actually example directory, and this is example file.txt. And right here you see the date and time, and then here's the file size. And then here is the data log that we've been working with, and it's date and time. And I see the date and time isn't correct because I don't have a clock to set it with. And then here's the total number of bytes right here. So the reason that this date is correct is because I created it manually on my computer before I put the card in. to demonstrate what it did with directories. So that's how you read what's on the card. And we're going to come back to this in a second, because we're going to go do one more thing, and it may create a file. It may not. It depends on where we leave it. But we have one more thing to show you with these, and that is file manipulation, which is like creating and deleting files. So this sketch, here we go from the top. Again, we're including everything, sd.h, creating our output for the pin mode 10 and down through card initialized. If you kind of look back, you'll see this whole section is the same across all these sketches right here. And then we say on the SD card, does the file example.txt exist? If it does, we're going to print out to the serial port example.txt exists. If it doesn't, we're going to say it doesn't exist. Then we're going to actually open a file as file write, and we're going to close it. That creates basically a blank file on the card. We're going to check again, does it exist? And if it does, we're going to say it exists or it doesn't exist. And then we're going to remove it. So we come in here and do sd.remove, basically a delete for best description of it. And then we're going to come down and we're going to say if it exists, we want to say print it out that it exists or doesn't exist. So you kind of know how it's going to come out when this runs. So let's go ahead and upload it. And we go to serial monitor. And it looks like I'm just putting these things in order, but you really are in between here, creating a file right here and checking it again. So we create it, it exists. We remove it, it doesn't exist. So this shows you that it is adding or creating and deleting the file through this process. So every 30 seconds, we're going to do this just as an example. If I'd be able to stop it in the middle, I'd be able to go to my previous program and be able to see that that file exists, example.txt exists in the root directory. So that is pretty much everything that we were going to show you tonight on the SD card side of things. The data logger we've had some questions about logging data, so that's kind of why I wanted to cover it. This is a good example of how you can log data, whether it be position information via GPS or any kind of data logging like that. If you actually have certain sensors you want to log over a period of time, this is the kind of program you'd have to write to store that data and come back later on and pick it up. And you might want to do it more often than once a minute. I would think for temperature and humidity, once a minute is probably plenty. But if you're running lots of other sensors, it might not be enough information to be able to. You need to do more information more often to get the data you need to be logged properly. So, do we lose you, Bob?
No, I'm still here, but we lost the video.
Oh, okay. Yeah, because I get something else on your thing.
Yeah. Now, one little side note about this, you were putting everything as ASCII. You can do, instead of using the print or println, you can use the write and
Absolutely.
write in binary. And if you were really trying to squeeze space,